I got a music class too. I hate this class. They don't pay me enough. Oh, there we go. Hey everyone! Music 150, your professor here. Before I start this class off, are there any questions out there from the audience? Oh, yep, you. I hate this kid.
Hey, Professor, I just had a quick question. Happened right before I got here. So I ran into two spheres. One was 1 kilogram, and the other was 2 kilograms. They were connected by a 1 meter long rigid massless rod. And that rod was rotating clockwise about its center of mass at 20 revolutions per minute. So I was wondering, Teach, what net torque will bring the spheres to a halt in 5 seconds? Thanks.
Very good question, sir. We'll start this off with cue the music. Sorry I'm late, everyone. I had to turn a wife into an ex-wife. Give me that. Okay, let's pen. All right. So the question is very clear, and I have a drawing up here for it. What we're going to start this off with is the center of mass. And what the center of mass equation is, mTRT equals m1r1 plus m2r2. Now what this equation is it's the total mass and total radius distance, and then you add the two up. So let's take 1 kilogram, and let's make this the 0 point. So it'll be 0 meters. And then this will be 2 kilograms. And that's going to be a 1 meter distance. And this is going to equal, like I said, mTRT. Now let's divide everything by the total mass. And the total mass of this is 1 plus 2, 3. And the addition of 0 plus 2 is 2. So it's going to be 2 kilogram meters divided by 3 kilograms. 2/3 meters is your center of mass. All right, now let's get moving on. If you said that it was 20 RPMs, revolutions, 20 rev per minute, all right? What we're going to do is you got to multiply it by 1 minute, 60 seconds. And multiply it 2 pi radians, 1 rev. I need some of that. Okay, now we're going to have this times this divided by this. And then, of course, that's going to equal 2.094 radians per second. And what we call that, we call it angular, or we use that as the angular velocity. Now, what are we going to do? We're going to give me that. Angular, we're going to use this equation. It's a very good equation. We use it all the time in physics, right? All the time in Music 150 also. It's going to be the angular velocity final minus the angular velocity initial, all divided by time, because we're trying to get angular acceleration. We're going to try to get this angular acceleration to be isolated. So what we're going to do is it's going to end at 0, it's going to start at this speed, and we're going to divide it by the 5 seconds. So it's going to equal 0 minus 2.094, all divided by 5 seconds. And what does this equal? This equals a negative 0.4188. And that's radians per second squared. All right. Now what do? We got angular velocity and we got center mass. Well, I know what to do. It's to give me that. Give me a fist bump with that too. Yeah. We got this equation. That is torque equals I times angular acceleration. And you might be wondering what I is. Well, that's going to equal this easy and fun little boy we like to call I equals 1 to n, the summation of it from MIRI2, which is squared, right? So we use this little baby, and we plug it into this guy. Oh, look at that. You only do it from 1 to 2. Easy. Easy as that. Easy as a slice of cake on wedding day, which I don't have to go to anymore. M2R2 squared. Oh, look at that. Look at that. 1 kilogram. Let's plug in the information we know. Good choice. Okay, so this is where it gets a little confusing. Thank you. This is where it gets a little confusing. So the R is going to be from the center of mass. So this is going to be negative 2/3, and this is going to be a positive 1/3. Bam. And what does this equal? 4 ninths plus 2 ninths. Oh, I just love it. I just love it. I love it so much that I'm going to need some of that. Oh, yes. Okay. Let's not get too excited over here. Kilograms per meter squared. That's inertial mass. Yes. All right, so now that we have this, we have this. What do we do? Well, as you can see, it's just torque equals that times that. It can't be any easier. It really can't. It really can't. All you do is 2/3, and we're going to multiply it by the what? The negative 4.8188. Oh yes. Oh yes. Oh yes. Trick shot. That's going to equal 0.279 Newton meters. And what is that? That's going to be the torque. Negative 0.279 Newton meters. But since it is moving counterclockwise to slow down, we usually make that torque positive. The acceleration is negative because it is slowing it down. That is it for the question. Very good question. Let's continue Music 150. Thank you.